Welcome all of you. Now this is a B.Sc. third SEM Maths paper 1. All of you know that there are two papers in third SEM mathematics. First paper is type is like this. Paper 1 is algebra and number theory. In this first paper there are three topics. First topic is elements of set theory, 10 hours. Graph theory, group theory, 10 hours, number theory, 20 hours, total 40 hours. Now the first topic is elements of set theory, and set theory is very fundamental in all the branches of mathematics. In any branch of mathematics, you will come across this set theory. In this set theory, you are supposed to study from the definition of set and different types of sets and operations on sets, then relations, what is the relation, types of relations, and De Morgan's laws. It is called generalized De Morgan's laws. This is the syllabus. And second topic is group theory, and I explain a detailed syllabus of this group theory while starting with this topic. And number theory is 20 hours, and group theory, number theory are quite new. You are not studied this in earlier classes. But set theory you have already studied. Now I start with the definition of set. What is set? And then different types of sets. Next, operations on sets. What is set? How to define? Set is collection of, so the definition it is collection of well-defined objects. Well-defined objects. I already told you that you have already studied this set theory from fourth or fifth standards. Set theory in POC first year, second year also you have studied set theory. What is definition of set? How to define? Set is collection of well-defined objects. This is important. Well-defined. Group of objects do not form a set. Well-defined objects is important. What do you mean by well-defined? Well-defined means given an element, you must be able to say whether or not that element belongs to the set. Sets are denoted by capital letters A, B, C, or capital X, Y, Z, so on. Elements are denoted by small letters A, B, C, etc. There are two methods to represent a set. First one is, it is called set builder method. Set builder method. Or it is, second one is, it is called roster method. Roster method. In the set builder method, we write the set by stating the property from which elements of the set are obtained. In the roster method, we enclose elements of the set in between two brackets. In set builder method, say I write set of all natural numbers. Set of all natural numbers. You know that it is denoted by n. And second example is for set builder method. Suppose capital A is, it is set of all x such that x is less than 5, x belongs to n. See, this is called set builder method, or it is called a rule method. Here how we have defined this set? Capital A is set of all x such that x is less than 5, x belongs to n. Here the property is this, must be less than 5 and it is a natural number. So, what are the elements of this set? In the roster method, the same set can be written as A is equal to 1, 2, 3, 4. because natural number starts from 1, less than 5 means 4. So these are the two different methods to represent a set. One is set builder method, second one is roster method. Now some important standard sets that we come across often are like this: set of natural numbers, set of integers, it is also denoted by Z, set of rational numbers, set of irrationals, set of real numbers, set of complex numbers. What are natural numbers? Starts from 1 and these are infinite. What are set of integers? Includes 0, plus or minus 1, plus or minus 2, so on. This is also infinite. What is set of rational number? All these are very elementary and all of you know this one, but once again I repeat this one. What are rational numbers? Rational numbers means numbers which can be written in the form of P by Q, where P, Q are integers and Q is not equal to 0. This is the definition of rational number. Any number which can be written in the form of P by Q is called rational number. Irrational means which cannot be written in the form of P by Q. What are the examples for irrational numbers? Root 2, root 3, they are all irrational numbers. What is set of rationals? It is union of rationals and irrationals. See, I have used union here. That is called operations on set. Next I explain what is union, intersection, difference, how it is defined. Set of reals means it is the rationals and irrationals numbers. Rationals and irrationals. What is complex number? That also we have studied. Complex number means a numbers in the form of x plus iy, where xy are reals and I is imaginary unit. It is defined as root of minus 1. This is called set of complex numbers. So we are these sets, and you know that all these sets are infinite. Infinite. So what are infinite and finite sets? See, these are the standard sets: natural numbers, integers, rationals, irrationals, real numbers, complex numbers. Now see the types of sets now. First is finite and infinite sets. Finite and infinite sets. Can you give any example for finite set? Finite set is set of all the students studying in 3rd semester G.C.COLLEGE ANKOLA, B.Sc. B.Sc 3rd semester G.C.COLLEGE ANKOLA. That is finite set. All these students studying in 3rd semester of our college belongs to this set. Infinite means which is not finite. Elements are infinite. Example for infinite set is naturals, reals, they are all infinite. If I define A is set of all the students, set of all the students, then is it an infinite set? No, it is a finite set, because we know what are the number of students. If you take the students all over the world, then we can count how many students are there, mainly in terms of crores, but it is a finite set. Infinite set of all stars in this side is infinite. Finite, infinite sets. Now operations on sets. Operations on sets. First is union. Union of two sets. Second, intersection. Intersection of two sets. Third one is difference. Difference. Union, see, I define like this. All of you have studied this one, but set starts from this. Operations on sets. Union, see the notation I define in terms of this mathematical notation. Mathematics has its own language. we define like this: A union B is set of all x such that x belongs to A or x belongs to B. This is called union definition. How do you read this one? This is called set builder method. We denote this set by this notation only. Now onwards. A union B, this is union notation. Set of all x such that x belongs to A or x belongs to B. What is intersection? It is denoted by this: A intersection B. A intersection B is set of all x such that x belongs to A and x belongs to B. Can you find any difference between this OR and OR means x belongs to union of A and B if it belongs to at least A or B. If it is in A, then it belongs to union, or in B, then also it belongs to union. But in intersection, if it both belongs to both A and B, then only it belongs to intersection. I give one example here. Suppose A is 1, 2, 3, 4. Some set I have taken. B is 2, 3, 4, 5, 6. Then what is A union B? A union B is 1, 2, 3, 4, 5, 6. This is union. Belongs to A or B. And A intersection B is belongs to both A and B. What is that? 2, 3, 4. This is intersection. Union, intersection. What is difference? Difference of two sets A difference B is denoted by this notation. A difference B means it is set of all the elements belongs to A but doesn't belongs to B. Which belongs to A but doesn't belongs to B. What are the elements which belongs to A but doesn't belongs to B? Only one here. A difference B. A difference B belongs to A but doesn't belongs to B. What is that? Only one. What is B difference A? Belongs to B but doesn't belongs to A. What are that? Only 5 and 6, because 1, 2, 3, 4 are there. 2, 3, 4 are in A. Only 5, 6 are not here. Now from this A minus B and B minus A, what do you observe? A minus B is not equal to B minus A. A minus B is not equal to B minus A. But here, union and intersection, they are commutative. Union and intersection. Commutative means A union B is equal to B union A. A intersection B is equal to B intersection A. Their union and intersection are commutative, but A minus B is not equal to B minus A. Some more properties you have studied about union and intersection, that I state here. Properties, only statement. And proof, we consider only De Morgan's laws. That is also generalized De Morgan's laws, because up to De Morgan's laws of two sets you have studied, we consider generalized De Morgan's laws. Properties of this union and intersection. Properties. First one is A union B is B union A. A intersection B is B intersection A. Suppose A and B are any two sets. Third one, A union B union C is equal to A union B union C. What do you mean by this property? Associative. Union of three sets is associative. Similarly, intersection, it is also associative. Is A intersection B intersection C. A minus B is not equal to B minus C. Now see, these are some elementary properties, and proof is obvious. You can easily prove this one. After this, null set. Concept of null set is very important. What do you mean by null set? It is also called empty set or void set. VOID, void set, empty set, null set, same meaning. Denoted by this notation, pi. Empty set means a set which doesn't contain any element is called empty set. Concept is very important. Null set is the set which contains no elements. What is example? I give for one example for null set of all x such that x square plus 1 is 0 and x is real. This is null set. Because there is no such real x which satisfies x square plus 1 is 0. If you solve x square plus 1 is 0, that are the elements of the set. What you get? Plus or minus I. That is not a real number. Therefore, this is the example for null set. And one more is singleton set. Singleton set. Singleton set means a set which consists of only one element. It is called singleton set. This is singleton set. This is null set. And consider one more example. A is equal to 0. This is not a null set. It contains one element, 0. Null set means it doesn't contain any element. So what you have studied? Finite, infinite sets, operations on sets, union and intersection. Then what is null set? What is singleton set? One more important concept that you have already studied, it is complement of a set. Complement of a set. It is denoted by this notation. Suppose A is any set, complement of A is denoted by this notation, A dash or AC. While defining complements of a set, we require universal set. You know what is universal set? Universal set means if we are discussing any number of sets, suppose A, B, C are different sets that we are taking into considerations, then all these sets are subsets of a big set. That is called universal set. For example, if we take A is equal to 1, 2, 3, B is equal to some finite sets, I take 2, 5, 7, C is equal to 101, 104, 110 sets. These are some sets which are in discussion, and all of these sets are subsets of, we can take natural numbers. This natural number is called universal set here in this case. So what is universal set? All these sets which are in discussion are subsets of a big set, and that is called universal set, and it is denoted by this notation here, universal set. So one more definition, universal set. Now we define what is complement of a set. Complement of a set means it is denoted by A dash. It is set of all x such that x doesn't belongs to A and x belongs to universal set. This is the definition. Complement of A means it doesn't belongs to A, but it belongs to universal set. Take this example. What is the universal set? That is important. The universal set that we fixed is important in the discussion. Natural numbers we have taken here. What is A dash here? A dash is set of all the natural numbers x. X is greater than 3 and x is a natural number. This is A dash now. Greater than 3 and natural number. This is important. So what is complement of a set? Complement of a set, A is denoted by A dash and it is set of all x such that x doesn't belongs to A, x belongs to U. So complement of a set, universal set, these things you have studied. What are the types of sets? And one more thing I used here, subset. one more concept it is that you have already studied. What is subset of a set? How to define subset of a set? Complement, I think it is clear. What is complement of a set? What is subset? Subset of a set. Suppose A and B are any two sets, then A is said to be subset of a set B. Subsets. A is said to be subset of B if all the elements of A are elements of B. Example I give. A is suppose 1, 2, 3. B is 1, 2, 3, 4, 5, 6. Then A is subset of B. But you can see here B is not a subset of A. B is not a subset of A. A is subset of A. Suppose A is subset of B, B is also subset of A, then we say that A is equal to B. A is equal to B. Equality of two sets. See, in elementary treatment, two sets are equal means one is exactly the duplicate of the other. Exactly same as the other. In elementary treatment. But in later on, while studying set theory, you will come to know that two sets are equal means they may not be duplicate of the other. There is we define in some other way when the two sets are equal. But now in elementary treatment, if A is contained in B, B is contained in A, then A is equivalent to B. Now here I have taken some simple example, 1, 2, 3, very elementary example. But suppose two sets are given, A and B. How to prove that A is contained in B? We use this technique. We take any arbitrary element x belongs to A. Any arbitrary element. Then we prove that this arbitrary element belongs to B also. If x belongs to A implies x belongs to B, for all x belongs to A implies x belongs to B, then A is contained in B. We use this technique here. So, what is subset? Here sometimes B is called superset and A is contained in B also we take, or B contains A. See, different terminologies are there. A is subset of B, A is contained in B, same. B contains A, that is also same. This is about subsets. How do you prove that A is subset of B? We take any arbitrary element, x belongs to A, and we prove that x belongs to B also, then A is contained in B. How do you prove that A is equal to B? We prove that A is contained in B, B is contained in A, then A is equal to B. These are very important because while studying further some concepts in set theory, you need to prove that two sets are equal. A is equal to B. Then how do you prove that A is contained in B, B is contained in A? How do you prove that A is contained in B? We take one arbitrary element x belongs to A and prove that x belongs to B. Then for all x belongs to A, x belongs to B. Therefore A is contained in B. So these are some elementary concepts in set theory. Actually, all these things you have already studied in earlier classes, means in B.Sc classes. Only I have tried to revise these things.